Okay, so here we find ourselves on 108. Like I said, we're kind of done with all the math just for math's sake. Now we really get to dive in and actually get into some electrical work here. But you're going to see here too, we do have to read chapter 3 in the EWR as well. So anyway, dwelling circuit requirements, outlet locations, and general lighting loads. So a lot of good stuff here, a lot of important stuff. Again, I think this is going to be a little more fun, a little more kind of challenging in a good way. And then you see chapter 3, we hit on a similar topic, determining the required number of branch circuits, lighting outlets, and receptacle outlets. So very much dealing with the same thing here, and you're going to see a lot of overlap, which I think is a really good thing. So a couple key points I want to hit though. So again, as we said, lesson 108. So a lot of this we're gonna study comes right out of the NEC Article 210.52 to be specific. And I pick out this little chart out of your textbook here, really only for one reason, but they tell us, and we'll talk about what some of these mean later, but so for our small appliance circuits, we need to provide a 20 amp circuit, and we need 2 of them in a dwelling, but you'll notice in a non-dwelling, we need none. Same with your laundry, 1 in a dwelling, 0 in non-dwelling. Bathroom, same story, and the reason I highlight that is because all of these rules in 210.52 apply to dwellings only. Okay, so they do not apply in a commercial building. Some of the only codes we're going to talk about that actually do apply to both dwellings and non-dwellings are going to be your GFI rules, things like that. But as far as your number of receptacles required, spacing of receptacles required, pretty much none of these are going to apply to a commercial building or a non-dwelling unit. This is dwelling units only here in this case. Another important term, I don't know that they do such a good job explaining, but it is very important, is the term continuous load. Okay, so the first thing we got to define, what is that? That's going to be any load that's expected to operate for 3 hours or more. Okay, and I can tell you any of your HVAC, by definition, whether they're going to run for 3 hours or more, are considered continuous loads. Okay, and that's a term you're going to see a lot as well. But so, okay, what does that mean to us? Why do we care? Well, essentially that means that our circuit must be sized 125% of the load. Okay, so if you do the math, if I have a 16 amp load, my circuit needs to be 125% of that. Doing the math comes out to 20. But it's kind of interesting here. Another way to say this, and you're going to see it both ways, or the load is only 80% of the circuit size. Okay, so again, I could say if I have a 20 amp circuit and it's a continuous load, I can only load it up to 16 amps. Okay, and that doesn't sound right, but trust me, the math works out, and we'll see here as an example. A 16 amp load on 20 amp circuit. 16 amps times 125% equals 20 amps. Or the other way to look at that, 20 amps, if we only take 80% of that, comes out to 16 amps. So the math is saying the exact same thing. Those things are said 2 different ways, and you're going to see them said that way, so you got to get familiar with that. But the reason that works, if you're kind of a math person, you want to know, it's basically a reciprocal factor, I think is what they call that. So 1 divided by 1.25 equals 0.8, or the opposite, 1 divided by 0.8 equals 1.25. So mathematically, that's why that happens. But again, you just have to consider, and when you see those phrases so you don't get tripped up, basically the circuit has to be a little bit larger or the load has to be a little bit smaller, but don't go vice versa. If the load is bigger than the circuit, we have a problem, and you've probably confused this formula here at some point. So receptacle placement. This is going to be very brief. Please read the text carefully. There's a lot of good information in there. But receptacle placement, there's a couple of key points for general areas we got to get to know. So first off, what areas are we talking about? Where do these rules apply? That is essentially any habitable room. So basically a room where you're going to spend any significant time, living, sleeping, reading, working, anything like that. So specifically living rooms, bedrooms, dining rooms, studies, finished basements. Okay, emphasis on finished basements, because we do not apply to unfinished basements, garages, foyers, bathrooms. Kitchens kind of have their own set of rules we'll talk about specifically later on. And in fact, all these rooms sort of have some specific things we need to talk about, and we'll hit those in depth in later chapters. But for now, again, think about living rooms, bedrooms, studies, things like that, where we're going to spend time living in. So first rule, probably the most important. No point on a wall may be further than 6 feet from a receptacle. Okay, so what do we mean by that? Think about it. So basically this door kind of breaks up the wall space. So we start our measurement here. If I can come this far, 6 feet, until I have to hit my first receptacle. It can't be any greater than 6 feet. And it does wrap around corners there, you'll notice, okay? So that seems pretty straightforward, but I'm going to throw this in there. How is this okay? I have 12 foot between these two receptacles. We kind of have to think about that. If I go to any point in this wall space, if I go 6 foot this way, I need to hit a receptacle. If I go 6 foot that way, I also need to hit a receptacle. So in other words, another way to say this is my receptacles may be spaced 12 feet apart. Again, and the way to imagine this, if you have a floor lamp and you sit there, it has a 6 foot cord, that thing better be able to reach one of these receptacles either side. So you might see that called the 6 foot rule, you might see it called the 12 foot rule. We mean the same thing, and that's why you kind of have that interchangeable language there. The next one I want to hit, any wall space 2 foot or greater requires a receptacle. So in this case, this is a sliding door here, and this is a center partition between the two. That wall space is 2 feet or greater, so therefore I need to have a receptacle in this wall space. Were this 23 inches or less than 23 inches, I would not need that receptacle there. Any wall space 24 inches or greater, I need a receptacle. The last one they really harp on strongly for some reason, I'm not sure, but fixed panes of a sliding glass door do count as wall space. So again, this is a sliding glass door here, sliding glass door here. Here's my sliding section, okay? This is then the fixed glass section. That does still count as wall space. Same thing if you have maybe banisters for staircases, something like that. They do still count as wall space, all right? And again, read the book. There's a lot of fine points and things like that that I'm not going to spend time on here, but please be sure to read that carefully. Ton of good information in there as well. So, required receptacles. We talked about spacing, but now, what rooms do I need receptacles, maybe how many, that sort of thing. And this is a pretty long list again. Be sure to read the textbook here carefully. But any hallway 10 foot or longer, I need at least one receptacle. Okay, that's the minimum. I never have to go above one receptacle. If it's 20 feet, 30 feet, 40 feet, the only rule is 10 foot or longer, I need one minimum. So a 100 foot hallway, I still only need one. And that's important to remember, it's all minimums here. We can always go above that. Foyers larger than 60 square feet need one receptacle in each wall space. I don't think that comes up a lot. It gets a little tricky when you try to figure all that out, but essentially foyers, if they're sort of normal size, we don't need them. When they get larger, then we get into needing that one receptacle in each wall space. So outdoors, I'm going to need, at a minimum, one receptacle in the front, one receptacle in the back. You get into patios, decks, things like that, it can tend to go up. So again, check the text carefully for that. For HVAC equipment, I need one receptacle within 25 feet of that equipment. That's for servicing. Sometimes, for instance, if you have an air conditioner out back, maybe this one receptacle in the back of the house can also apply and meet this requirement as well. So you can do two birds with one stone here too if you're creative. For an attached garage, we need one receptacle in each car bay. Okay. Detached garage, if there's no power to the building at all, nothing required. Otherwise, it's exactly the same as an attached garage as soon as we run power out there. For unfinished basements, one receptacle minimum. That will be GFI protected. Same with the garage, come to think of it. But an unfinished basement, one receptacle minimum. As soon as we finish that basement, though, it now applies to the normal rules as any other finished room. For your kitchen, we actually have a 4 foot rule, so no wall space is more than 2 foot from a receptacle. We have a whole chapter on just that, so we'll hit that later, a little bit later on. Bathroom, minimum of 1, and again, there's some more finer points, but we'll hit a chapter on that specifically as well. Laundry area, same story, minimum 1, more to come later. So again, there's a ton of stuff in your lesson 108 there, same thing. Chapter 3, so be sure to read those carefully. Keep in mind some of the rules we just went over, and I think we'll find